Hello there. So, my brother is really nearsighted. Like, his vision is really bad. So bad that his glasses have to have custom lenses. These lenses are super thick and a weird oval shape. They aren't your standard prescription glasses. So, they don't fit normal frames, and he has to have custom frames for them. Well, his custom frames, which are like 6 years old, finally broke. And he has to leave for a work trip out of state in just a couple days. So he doesn't have time to get new custom frames made before he has to leave. So let's 3D print some. Okay, so my goal in this episode is to make 3D printable glasses frames that fit these specific lenses. The final frames aren't going to work for any other lenses, but the design approach that I show here could be used to make different frames that fit any number of other sizes or shapes of lenses. I think I want to make the rims out of TPU so that they're flexible enough to snap the lenses in and also durable enough that they won't break easily. One of my favorite things about TPU is how durable it is. It's perfect for making 3D printed parts that need to be rugged and withstand constant rough use. I want to make the stems out of PLA so that they're a little more rigid and also so that I can use a heat gun to soften them up a little bit after they're printed and reshape them to adjust the fit. If you want to try printing these out or use the model as a base to remix into other frames that fit different lenses, you can get it for free on my thangs.com profile. The link for that's down in the description. I also have affiliate links in the description for the materials that I used, as well as all of the 3D printing hardware that I use, in case you want to try any of that out for yourself and also want to help support the channel in the process. Now, let's get to designing these in Fusion 360. Alright, so this project is a little different than what I'm used to. Because the lenses have so many organic curves and ridges, I can't really take good measurements with my calipers like I normally would. So instead, I'm just going to have to work from references. I'll talk more about how I'm going to do that in just a second. I'm going to approach this project as two phases. The first phase is just getting a thin rim design that the lenses can snap into snugly. Once we have a printable rim that interfaces with the lenses properly, then we can move on to the second phase, which is building the frames around the rims. The second phase is going to be much more organic and just kind of by feel, while the first phase is going to have to be much more precise. Splitting the project up like this means that I can prototype the fit of the lenses into the rims without having to print the entire frames every single time. That'll save us both time and material. This is an approach I picked up over the years from watching James Bruton, who, in my opinion, is arguably YouTube's greatest 3D printed robotics maker. He does a similar thing for fitting bearings into 3D printed parts. If you like 3D printing and robotics, definitely check out his channel if you haven't already. There's a link to it in the description. Okay, so I'm getting a canvas set up to use as a reference. I got this image by just throwing the lenses and half of the broken frames on my home office document scanner. I also threw on something that I knew what the dimension was. In this case, I just used a coin. You could also just use your phone to take a picture, but the main thing to aim for is getting the picture as straight on as possible. The best way that I've found to do that is to get as far away as possible and use the telephoto lens to zoom in as much as you can, which removes as much perspective as possible. That's exactly what I had to do for the next canvas, which shows the edge profile of the lens. Once you bring your image in on a canvas, you can then use the object browser on the left to calibrate the canvas. To calibrate the canvas, it just has you select 2 points of a known distance, and then you can tell it what that distance is. In this case, the sides of the coin. Once you confirm it, the canvas is automatically scaled to match that dimension. Next, I used fit point splines to trace around the edge of the lens. I did a first pass just getting them pretty close and then went back around and tweaked and adjusted the splines until they were right on the edge of the lens. Once I was happy with the outline, I used an offset to make an actual profile that could be extruded. I then moved on to outlining the edge profile of the lens. Again, I did a first pass just getting pretty close and then went back over my lines to get them exactly where I wanted them. As I got the lines where I wanted them, I wrote down their dimensions in my notebook since I won't actually be using this profile to make the rim. I'll be recreating this profile in a new sketch to use for cutting the ridge into the rim. Once I got my dimensions, I extruded the rim and set up a plane as close to perpendicular as I could. I then made a sketch of the side profile on that plane and made sure that the inside edge of it lined up with the inside edge of the rim. After I was done with the sketch, all I had to do was create a sweep of that profile following the inside edge of the rim. The last thing that I did was just some cleanup to prepare the model for 3D printing. Specifically, I put a small chamfer on the bottom edge to compensate for first layer expansion. After I exported the rim model and got everything loaded up in Cura, I made a mirror copy of it to use for the opposite lens. Everything looked good to go, so I sliced it and got it started printing. Both rims printed perfectly on the first go, and the lenses snapped right into them and fit just right. They were loose enough that they could fit into the rims, but snug enough that they wouldn't fall back out. I guess this is just a testament to taking good measurements, or in this case, using good references. As the old saying goes, measure twice, print once. And it's a good thing that they printed and worked out on the first try, because I'm running out of time. I've just got the rims made, and I've still got the entire frames and stems to design before my brother has to leave. So let's hurry up and get that done. Okay, so I started by duplicating the profile of the rim that we just made, and then figured out the spacing between the lenses. I did this just by measuring the width between the nose pieces on the original broken frames. Once I got that spacing right, I kind of just started modeling the rest of the frames organically, feeling out what looked best. I also wear glasses, so I use my own glasses as a reference as well. Just taking measurements here and there and looking at them to see what shapes made sense. The main part that I was looking at my glasses for was the nose piece. My glasses have a nose piece that are built into the actual rims, which is exactly how I'm going to need to model these frames. The whole process of modeling the frames really was just a bunch of trial and error and seeing what felt right. The only part that needed any kind of technical consideration were the hinges, but they're just simple pin-in-hole hinges, so they didn't require all that much planning. I wanted the hinges to be pretty tight fit, so that the stems would stay in place where you put them. I specifically didn't add any tolerances between the parts to make sure that they were tight. If I was printing both the rims and the stems in PLA, this would have been a problem, because they wouldn't have been able to fit together at all without one of them breaking. But since the rims are printed in TPU, the hinges flex easily out of the way and let the stems pop into place. We're running out of time. Well, as Adam over at North of the Border likes to say, it's time to make these frames not just good, but good enough. Let's get them finished. I'm pleasantly surprised that both the rims and stems printed out and fit well on the first try. There were some minor issues with bed adhesion on the stems, but that's entirely because of the material that I used. I love the look of the matte black PLA, but man does it hate to stick to the build plate. But that's really what you get with any matte filament. Thankfully, the section that wasn't sticking formed a little blob, and I was able to just pause the print and use some flush cutters to trim it off. The lenses still fit into the rims properly, even with the full frames around them, and the stems popped right into the hinges of the rims. They're just tight enough to hold their position, but loose enough that you can move them freely. After I got the pieces all assembled, my brother came over, and we used a heat gun to soften up the stems a little, and readjust them to fit properly over his ears, and on the sides of his head. After just a few minutes of adjusting, he said that they fit and felt better than even his original frames. This was a really fun project, and the quick deadline added a little bit of tension that most of my projects don't normally have. 3D printing random figures and trinkets is fun, but I really love 3D printing when it can be used to solve a real-world problem and make something functional that's even better than the original thing it's replacing. If you want to see the full, unedited, real-time process for designing this model, including the chaotic ambience of a house full of kids, I've uploaded that under design sessions. A link to that video is in the description below. If you liked the video, then like the video. If you didn't like the video, then dislike the video. Either way, tell me what you think down in the comments. If you want to see more videos about random stuff, then subscribe. You know how YouTube works. Stay Moxious.